you're looking at a graph and you gotta answer A, B, C, D. So determine the period. The period you start. If we start right there and we go up and back and then down and up, that is one period. Because now it's just going to start again. So that is cycled through once. So now it's going to go up and down, down and up, and that's 2. So one period is going to be from 0 to pi. So the period is just pi, or 180. 180 degrees, it makes its cycle. The max and the min, the max is 2, and the min is a -4. And then now we gotta find the amplitude. So the amplitude is how far up and down you're going. But it has got to be from the midline. So right there, I think that's cutting the graph in half. So from here, I go up 1, 2, 3, then I go down 1, 2, 3. So your amplitude is going to be 3. So above the midline, I'm going 3 up and I'm going 3 below. So my vertical shift, now this sine starts at 0, and it's moved that dot down 1, it's moved every dot down 1, so your vertical shift is -1. So your amplitude, if you start at 0 and go up to 3, and then back down to 0, and then down to -3, and then up to 0, so they have just moved all these dots just down 1. Alright. B, now let's see. Find the measure of angle B. So this angle right here. And I am going to make a triangle. So that's a 90. This is 1, 2, 3 long. And this is 1, 2, 3, 4 tall. So if I know how tall it is and how long it is, I can use trig to find the angle. So from B, if I mark it from B, this would be the opposite and this would be the adjacent. So I'm going to do tangent from B equals opposite over adjacent equals 4/3. So now solve for B, undo the tangent, do the inverse tangent of 4/3, and angle B would equal 53.1 degrees. And that's it. Next one, find the period of this graph. So the period is just from start to end, and then it just starts repeating. So if I start it right here, I'm going to go up and over and down, and that is it. That is one cycle. No, that's not one cycle. I have got to go over. Okay, that is one cycle, because where I started my first move was to go up, and then over, and then down, and then over. Okay, so the red is one period, the black is one period. So how long does it take to make a one period? One period, it takes me 1, 2, or I guess 2, 4, 6. It takes 8 units on the number line before it starts to cycle again. So I go from 8 to 16, then it's going to start over. Whoa. Okay, there we go. So the parent function is sine. So sine starts at 0. At 180 it's 0. At 360 it's 0. At 90 it's up 1. At 270 it's down 1. So that is sine. Now it looks like they've tweaked it up. They've transformed it. So we need the amplitude, I need a period, and we need maybe a vertical shift. Alright, so the amplitude, let's see. That right there is the highest and that is the lowest. And to get from the highest to the lowest, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So that means my midline is at 1, 2, 3, 4. So right here is the midline. So let me count. If I go 1, 2, 3, 4 down, 1, 2, 3, 4 up. Okay, so your amplitude is 4. So I'm going to go up 4, I'm going to go down 4. And my period, so I'm going to start here at 0, and I go up and then down, and then down, and then up, and that is 1 period. So it looks like my period has not changed. My period is the same. My period is 2 pi, or 360, and the vertical shift, they have shifted everything up. Let's see, what have we done? Everything up twice. Because I used to start at 0, and now I'm going to start at 2. So my vertical shift is up 2. Okay. So look, if your amplitude is 4, so I start at 0, and then I go to 4, then I go back to 0, then I go down to 4, then I go back to 0. So the vertical shift is, whoa, up 2. Took this dot, up twice, 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 this dot, up twice. Okay, now story problems. So angles of elevation, angles of depression. You gotta draw a triangle. To illuminate the entrance of an apartment building, a nightlight is mounted on a 6.6 meter pole. So I got a pole. That is 6.6. The base of the pole is 24 meters from the entrance. So if I go over here, 24, here's my entrance. Find the angle of depression from the light. So your light's right here, and it is going to shine to that point. Now your light normally looks straight across, and that is your line of sight. So this is the angle of depression. If the light has to turn down, that's the angle of depression, and that is the angle of elevation, and they are the same. They're going to be the exact same. So I'm going to mark up my triangle from here. If I go from here, that's opposite, that's hypotenuse, that's adjacent, and I'm going to use this with this. So I'm going to use opposite with adjacent. I'm going to do tangent. Tangent from that angle, whatever it is, I don't know what it is, but it is opposite over adjacent, 6.6 over 24. So now undo your tangent, inverse tangent. So inverse this, inverse this on my calculator. The inverse tangent is 6.6 divided by 24, and we're going to get 15.376 degrees. The next problem, a child holds the end of a kite string 36 inches above the ground. So there's a kid. He's holding a kite. So the kite, somewhere like right here. Okay, the string's taut, so the string's tight. I'm going to make 68-degree angle with the horizontal. So if I go horizontal, that is 68 degrees. How high off the ground is the kite? If 540 inches of string, so this is the string, 540 inches of the string. And it wants to know how high the kite is off the ground. So the ground that, whoa, is the same ground the kid's standing on. So this, but this much is 36. Because the kid is holding the string 36 inches above the ground. So from here to the ground, that's 36. And they want, let's find this piece, and then we'll just add it to the 36. So my triangle, I'm going to mark from here. So that's opposite. That's hypotenuse. So I'm going to do sine. Sine from the 68 equals x over 540. So times this side by 540 times this side by 540. So 540 times sine of 68. So x is 500.679 inches. So I'm going to take the 500.679, add the 36. You should get 536.679 inches. That's how high the kite is off the ground. Oh, what is the function? Okay, this function, what's up, Cal? Okay, on the test I'll tell you the parent function. So the parent function is sine, and this parent is also sine. So the parent starts at 0, 180, 0, 360, 0. At 90 is up 1, and then at 270 is down 1. So that is the parent. Okay, so I need amplitude, period, and the vertical shift. So to find the amplitude, you just find the midline. Cut it in half. It looks like that's my midline, and I'm going to go up 1 and down 1. So my amplitude has not changed, it's 1. My period, I'm going to start here. Now look, originally you start and you go up 1 and then down, but they are going to go down and then up. So my amplitude is actually going to be a -1. So the negative is just going to change the direction. And then they're going to go up 1 and stop. Okay, now that is one complete cycle. Because then you're back to where you start. Your first move is you go down, then up, then down. That's another cycle. Then you'd start over again. Down, then up, then down. And that would be 3 cycles. Alright, so your period start to end is pi. And your vertical shift, looks like they took everything up 2 dots. So if my amplitude was a -1, I'd start at 0. And my period was pi, so I'd end at pi. And then halfway I'm at pi. Then I would go down 1 and then up. So I took this dot up twice, this dot up twice, this dot up twice, this dot up twice. So your vertical shift, everything went up twice. Okay, so now your period, here's what we got to change. Your period is 180. That means it is going to look like this. Y equals -1 times the sine of 2x plus 2. Because to get 180, you are going to take 360 and divide it by 2. And that is my 180, or pi. Okay, this one, let's do the parent. Starts at 0, ends at 2 pi. up one, down one. I need amplitude, period, vertical shift. Okay, so they have stretched it out. So your period is going to start, it's going to end at 4 pi. So that means I have stretched it out. So I'm going to take 360. 4 pi is the same as 720 degrees. That's 2 360s. So 360, I'm just going to times it by 2. And 360 times by 2 is 720. So that's how I got it. So timesing by 2 is the same thing as dividing by 1/2. 360 divided by a half, that's giving me my 720. So that means this: y equals something times the sine of x divided by 2. Okay, now my amplitude. Let's find the amplitude. The amplitude, here's my midline. And I am going 2 above and 2 below, so my amplitude is 2. And your vertical shift is 0. There is not one. So that is the function. Y equals 2 times the sine of x over 2. Okay, last one. How long does it take for the minute hand of a clock to pass through 8 pi over 3 radians? Okay, first of all, 1 pi is 180. So I'm going to do 8 of the 180s divided by 3. And I know that 180 divided by 3 is 60. So I'm really doing 8 of the 60s, which is 480 degrees. Okay, 480. Now on a clock. 480 is more than one spin. So 480, if I take away one spin, let's see what's left over. 480 minus 360, 0, 2, 1. 120? Okay. So now on a clock. 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You're dividing it up into 12 portions. So if you do 360 divided by 12, that means each portion is 30 degrees, which makes sense because that is 90. So 30, 60, 90. So if I have to make one spin, that minute hand is going to go all around at once. So every 360 equals 60 minutes, equals 1 hour. Okay, now I've got to go 120 degrees. So if I know that each number is 30 degrees, if I take that 120 and divide by 30, that means 4 numbers. So I'm going to spin around once, 360, that's an hour, and then I'm going to go 4 numbers, 1, 2, 3, 4, 30, 60, 90, 120. So that means if every number is 30 degrees, that's going to be 4 numbers times 30 degrees, and that's back to 120. I guess I want 4 numbers. Each number is 5 minutes, so 5, 10, 15, 20. 4 numbers is 120 degrees, but 4 numbers is also 20 minutes. So it is going to be 1 hour and 20 minutes, or 80 minutes, for the clock to rotate through 480 degrees. Okay, the very last one we did, reviewed at the midterm. Here's what you need to know. If we go from A, call this A, B, C. I go from A, and let's say that's a 3, 4, 5, and that is 3, 4, 5. So same triangle, copy paste. If I do the cosine of A, so if I put that there, cosine of A is adjacent over hypotenuse. It is 4/5. And so cosine of A goes there. Sine of B goes there. Because the sine of B is telling you to look at the same two pieces. The sine of B would also equal, sine is opposite over hypotenuse, so sine is 4/5. So those two are equal. So cosine from one angle is the same as the sine from the other. Or I could put here, what if I put cosine of B? So now if I do cosine from B, if I look from the B, cosine is 3/5. And that would mean the sine of A. So if I go from the A, the sine of A is 3/5. Sine of A is the same 3/5.